Principal, Dr. C. Ilanjanian, and all the faculties of Arunai Engineering College and all the faculties from STEKOM University. Welcome for this wonderful visiting lectures from Arunai Engineering College, Tiruvannamalai, Tamil Nadu, India. Welcome you all. Before that, I would like to thank the management of STEKOM University, Rector of STEKOM University, Dr. Joseph, and MC of this event, Ms. Novita, for organizing and giving such opportunity for this to our institution. We are always thankful for STEKOM University and doing such thing for the knowledge sharing for our students as well as for STEKOM University students. Thank you, one and all. Now I would like to introduce our faculty, Mrs. Sangeetha, Assistant Professor from Department of Artificial Intelligence and Data Science from Arunai Engineering College, to take over this session on cloud computing. Yes, please.
Thank you, sir. Good afternoon. I am Sangeetha, Assistant Professor of Arunai Engineering College. I am going to deliver the topic about cloud computing. The network streaming operation. Network streaming operation.
Hope you spell it well.
My screen is visible.
Yes, ma'am.
Okay. Today I'm going to deliver the topic about cloud computing. First, what is meant by cloud computing? Cloud computing. So cloud computing is on-demand delivery of IT resources, servers, storage, and software over the internet as on pay-as basis. Instead of owning and managing the physical hardware, users access services from the cloud provider, which eliminates together the process. Services can be accessed from anywhere with connections, offering flexibility and cost saving. Before the cloud computing makings, delivering computing services over the internet. The services include some servers, storages, databases, and networking over the software systems. It follows as pay on your services. Use pay only what can use for that. There is no need to buy or maintaining physical hardware devices. The cloud provider manages all the infrastructure and based on the networking systems. It allows us access from anywhere and through the internet connections. It increases flexibility and scalability for organizations, and it interact with the global collaborations with the cloud computing environment. It provide automatic overall cost of IT operations, making some cloud, Google Cloud, AWS, and Microsoft Azure. It reduces data loss through backup in multiple locations. It can host applications, websites, even entire businesses for an software environments. The user focuses only on using services and not on managing servers. Hence, cloud computing environment provide foundations of digital worlds. It mainly focuses on servers, storages, and databases, networking, and software environment. It follows a pay as you can go model. User pay only for what they use. The cloud provider mainly used to service given services to the cloud consumers. Next, how it is works. How it is works mainly based on-demand services, internet delivery. Next one, pay as you go pricing, remote storage. So first one is on-demand services. Cloud computing works throughout the internet. It offers on-demand services. Any users need them. User can apply any applications data remotely. It provides maintenance and manage large data centers for the on-demand services. Like internet delivery mainly focuses on the data centers contains thousands of connected devices. The services are virtualized and server can host many users throughout the networks. Next, third one is pay as you go pricing. Pay as you go pricing ensures users pay only for users capacity, what they drive and what they use from the network. Storage is remote. Meaningful files are stored in online, not only on local disk. So user can access files anywhere throughout the network. So internet bandwidth plays a key role in speed and performance. Cloud software automatically scale up or down as our needed. Security layer or encryption protected in storage information. Computing, the simplification access to the particularly IT resources. Everything happen virtually and reliability as well as the speed. Remote storage mainly focus on multiple people to share and work on the same data. So on-demand services mainly focused on availability anytime user need them. Internet delivery focuses on services are virtualized, meaning one server can host many users. Pay as you go pricing belongs to pay what they can use. Remote storage is mainly focused on multiple people to share and work on the same data. The four properties belongs to reality and speed is working on the cloud computing environment. Next, cloud
Hello, ma'am. Hello?
please wait.
Oh, yeah, yeah.
Ma'am, my screen is visible. Ma'am, my screen is visible.
Yes, sure. Yes, ma'am.
Ma'am, my screen is visible.
Yes, ma'am.
Okay. Third one is cloud computing infrastructure. The cloud computing infrastructure architecture provides the cloud computing architecture belongs to cloud computing environment, servers, virtual desktops, software platforms, applications, and storage data. And that the end user having router and switches. The router having mobile, laptop, and printer. The switches belongs to different types of desktops. The architecture defines the structure of designs of the cloud systems. It includes hardware, software, storage, and network components. In that the several layers, physical layers, virtualization layers, and services layers are there. The physical layer is mainly used to contain servers, routers, and data centers. The virtual layer handle virtualization using hardware services. The virtualization provides the service layers, delivers SAS, PAS, and IaaS, software as a service, platform as a service, and infrastructure as a service. The management layer handles security monitoring and backup information. So cloud orchestrations ensures all parts will smoothly together to work in the cloud computing environment. The mainly focused on the cloud architecture focused on some scalability and reliability. So load balancing and redundancy prevents system failures for cloud computing infrastructures. Infrastructure. Next, API enable applications to communicate with the cloud services. Architecture also defines role with the provider, broker, and consumers. It forms the base for deployment and services models. Those it ensures smooth, efficient, and secure cloud operations over the internet. The physical layer is mainly focused on cloud servers, routers, and data centers. The virtual layer handles virtualization using hypervisor. The service layer delivers SAS, PAS, and IaaS to the user. The management layer handles security, monitoring, and backup with the cloud model. So, mobile, laptop, printer using the through router, the cloud computing environment, it retrieve from the virtual desktop or software platform or applications or storage data. Next, the multiple desktop systems using switch with the
Hello,
internet
ma'am.
and access
Pardon.
cloud data from the virtual desktops.
Pardon, ma'am. For the presentation is still in the first page, not moving.
Ma'am?
Yeah, for the presentation still in the first page, not
Yes,
moving.
yes, yes, yes.
Yeah, for the presentation still in the first page, not moving.
My screen is not visible.
Not moving, ma'am.
Not visible.
Not moving.
Sir, no,
Not moving, ma'am. In the still in the first page.
still in the first page. Okay,
Yeah.
okay, okay, okay. Wait, ma'am. 2 minutes. Wait.
Yeah, right now is better, ma'am.
Okay, now visible, ma'am.
Yeah, yeah. Yes, ma'am. Is
Okay,
it
visible,
moving?
ma'am.
Yeah, yeah.
First page, second page, how it works, visible, ma'am.
Yeah, yeah. For the second is visible.
Okay, shall I repeat from this how it works?
Yeah, yeah. Please go ahead. Thank you.
Okay, data. How it works? Shall I repeat from this second slide?
Yeah, yeah. You can continue before.
Okay. How it works? How it works belongs to on-demand services, internet delivery, pay-as-use, go pricing, remote storage. So on-demand services available anytime users need availability. Internet delivery is mainly focused on it provides, maintain and manage large data centers over the internet. Pay-as-use, go pricing is mainly focus on this. Users pay as you what you are going to retrieve from the cloud services. Next, remote services is mainly used to um, share multiple people to share work on the same data itself. Next, cloud computing environment. In cloud computing environment, the cloud computing environment depends on servers, virtual desktops, software platforms, applications, and storage data. The router connect with the mobile, laptop, and print through the router, the cloud computing. Next, the multiple desktops using the switches to connect internet to the cloud computing. So architecture defines the structure and designs of the cloud systems. It includes hardware, software, and network components. So it contains the physical layers, contains several routers, switches, internets, and data centers over the internet. The virtual layer handles virtualization and hypervisors. Third one is services layer, depends on PAS, IaaS, and SaaS. SaaS, software as a service, infrastructure as a service, and platform as a service. The management layer handles secure monitoring and backups. The cloud orchestration includes all parts working smoothly together. So load balancing and redundancy prevent in the infrastructures. So resource pooling ensures efficient use of hardware resources. API enable applications to communicate with the cloud services. So it mainly depends on provider, broker, and consumers, and provided all deployment services with the internet. Ma'am, my screen is visible now. The cloud computing types.
Yes, ma'am.
Okay, next, the cloud computing types. There are two deployment models in cloud computing types. First one is deployment model, and second one is a services models. The cloud deployment models contains public, private, hybrid, and community over the models in the deployments model for the cloud computing. Services model, there are three types of services: infrastructure as a services, and platform as a services, and software as a services. First one is public cloud. The services offered to anyone through the internet, managed by third-party providers, AWS and Google Clouds. The cost-effective, less secure, since shared by the many users. Private cloud dedicated to one organizations, so it offers more security and control. Used by companies with strict data privacy needs. The community clouds based on shared by a group with common goals. Example, hospital sharing a healthcare cloud systems. It is a community-based cloud computing environment. Hybrid cloud, it is a mix of public and private clouds. Sensitive data stored in the private, general data in publics, provides feasible and resource usage. It enables data and appropriate probability, support disaster recovery and backups. Each model is chosen based on the needs. Next, cloud deployment model and services model. The cloud deployment model is a fundamentally determines whether the infrastructure focused on deployment exists and who owns and controls the infrastructure, also figure out the nature and the intention of the cloud. The services model, a model defines what kind of services the cloud providers uses, whether it is hardware, platform, or software. So services model description can be actively there are three types of services: IaaS, PaaS, and SaaS. So IaaS mainly focused on provides virtualized computing resources over the internet. So user manages OS runtime applications. Provider manages using infrastructure to the internet. Example is AWS, EC2. Google Compute Engine is infrastructure as a services. Next one is platform as a services. In platform as a services, example is a Google App Engine. It mainly focused on runtime OS and server storage. It mainly used in the applications. provide a platform allowing outcomes to develop and run and manage applications through the infrastructures. So SAS is a software as a services. It mainly focuses on Google Workspace, Salesforce developer. It can mainly used in everything, just as in software, deliver shared applications over the internet on the subscription basis. Next, cloud deployment model. So the cloud deployment model already told control the infrastructure and also figure out the nature and intention of the control. There are 4 types of cloud. First one is public cloud, private cloud, hybrid cloud, and community cloud. Public cloud is cloud infrastructure is owned and operated by the third-party provider. Private cloud is mainly used in a single organization. It can be physically located on premises or hosted by a third party. Next, hybrid cloud is a mix of public and private clouds, allowing data and application to shared between them. Community cloud, shared infrastructure for a specific community with shared concerns. In example, public cloud, AWS, Microsoft Azure. In private cloud, VMware private clouds. Hybrid cloud mainly focus on a company using both AWS and a local data centers. Community cloud is mainly used to run government healthcare or research collaborations. So in cloud deployment model, types of cloud computing, public cloud, private cloud, hybrid cloud, and multiple cloud. The public cloud is mainly for everyone to use throughout the internet. Next, the services are provided by third-party vendors like AWS, Google Cloud, or Microsoft Azure. The infrastructure is shared among multiple users, multiple tenant. It is cost effective as users pay only for what they use. The providers manage all hardware, software, and maintenance. Next, user don't need to buy or manage their own servers. Data and applications are stored in the provider's premises. So access is available from anywhere within the internet connectivity. So ideal from small business or startups needing flexibility. It offers high scalability and easy resource allocation. Security is generally strong but less private since data is shared. Suitable for non-sensitive workloads like email or file sharings. Upgrades and backups are handled automatically. Example, Gmail, Dropbox, or Google Drive. In short, it is cheap, flexible, and easy, but less secure. Next, private cloud. In private cloud, the private cloud is used by a single organization only. Infrastructure is not shared with other users. It can be hosted internally or by a third party provider. It provides high security and control over data and applications. Ideal for organization handling sensitive information. So resources can be customized according to company needs. So costs are higher due to private infrastructure setup used by banks or any other hospitals and government departments. It ensures compliance with strict privacy policies. So offer dedicated bandwidth with the computing resources provides excellent performance and a minimum downtime. It requires skilled IT staffs for maintenance, best suited for the large enterprises throughout the network. So VMware, vCloud, OpenStack, private cloud. It mainly used to secure and customizable by more expensive. Next, third one is community cloud. This is also called as multi-cloud with the community cloud. The community is shared by a specific group of organization. The organization have common goals or requirements. It helps them share resources while maintaining privacy. For example, a group of universities or hospitals. Data and applications are accessible only to community members. In a middle ground between private and it is a middle ground between private and group. So costs are shared among all participants. It improves collaboration and reduces duplication of efforts. Each member gets secure and reliable access. Management may be internal or outsourced by a third party. It supports projects that requires shared standards, offer moderate security and scalability. Example, government cloud for multiple agencies, useful organization with joint missions. It is also shared, secure and cooperative with the cooperative with the public and private cloud. So hybrid. Next one is a hybrid cloud. The hybrid cloud combines public and private clouds. The sensitive data stays in the private cloud, other data in the public cloud. So it connects both the clouds through the secure networks. It provides flexibility in where to store or run applications. It allows data transfer between environments easily. Businesses can use the public cloud for temporary workloads. So offer cost efficiency of public and security of private clouds. Useful during high demands or seasonal spikes. It provides better disaster recovery options and ensures data backup and continuity. Organization can make workloads between clouds as needed. Management can be complex but highly flexible. So example, company stores customers' data privately but uses AWS for app hosting. Supported by platforms Azure Hybrid and AWS Outpost. The mainly hybrid cloud is used compared to public, private, and multiple, flexible, scalable, and balanced. So public cloud allows the systems and services to easily accessible to the general public. Public cloud may be less secure, often to the email. Private cloud is mainly focuses on accessible with the organization. Community cloud accessible group of organization. It is a combination of public and private cloud. Hybrid cloud is a mixture of public and private. It is a critical activities are performed using private cloud and non-critical activities are performed using public cloud. Services model. So there are three types of services models are there: SaaS, PaaS, IaaS. So SaaS mainly use software as a service. PaaS is a platform as a service. IaaS is a infrastructure as a service. SaaS is a end user services. SaaS is a end user services. PaaS is a application developers. IaaS is a infrastructure and network architecture. So SaaS mainly focused on packaged software OS and application stack service and storage networks. The PaaS is a platform as a services for OS and application stacks server using storage network over the platform as a service. The third one is the infrastructure as a services is mainly used to infrastructure and network architecture. So it is mainly used to serve several storage networks. So IaaS mainly belongs to infrastructure as a services. PaaS is a platform as a services. SaaS as software as a services. So IaaS infrastructure as a service provides server storage and networking. User rent IP infrastructure instead of buying. So AWS EC2 Google Computer Engine is also an example of IaaS. Platform as a service provide an development platform. So developer build, test, deploy applications quickly. So no need to manage servers and organizations. It all example as a GAE, Google App Engine, AWS, Elastic means Claxed. Next, SAS, software as a service. It provides a development environment. Developer build, test, and deploy applications easily. So no need to manage servers or operating systems. Example, GAE, AWS, Elastic Bench Stack List. So software as a service provide ready to use software online. So user access application via the browser. Example, Gmail, Dropbox, Microsoft 365. So each mode offers a different level of control and responsibility. So infrastructure as a services deliver the technology infrastructure over the on-demand scalable service. IaaS mainly focused on physical machine, virtual machine, and virtual storages, etc. Usually build based on usages. Usually multi-talented virtual environment. It can be coupled with managed services for OS and an applications support. And also IaaS gives an most control compared to the SaaS. So PaaS lies between focused on an application development. All three together to form an cloud computing environment systems. They simply IT operation and reduces the business cost. So IaaS example is OPS services, entity communication, Terremark, AT&T based on GQ grid. Platform as a service. Platform as a service provide the runtime environment for application development and deployment, etc. PaaS provides often are required to support the complete life cycle of building and delivering web applications and services entirely from the internet. So typically application must be developed with a particular platform in the this cloud environment. Multi-tenant environment, high scalable multi-tier architectures. So PaaS example, Amazon Web Services, Azure, Rackspace joins 3 teras. Software as a services. SAS model allows to use software application as a service to end users. SAS services is a software delivery methodology that provides licensed multi-tenant access to software and it functions remotely as a web-based service. It usually built with passage on based on usages. It is a multi-tenant environment, highly scalable architecture. So SAS example, NetSuite, hosting, Google within cloud services, and Facebook, Salesforce.com. It is an SAS, software as a services, and this is a platform as a services. Amazon Web Service is also a example of platform as a services, and infrastructure as a services, OPS services, Terremark are the example of infrastructure as a services. Next, and this is throughout this we can use the cloud data from the cloud computing environment, Box, Netflix, YouTube, Gmail, Flickr, eBay, and this is the environments. So advantages: lower computer cost, improved performance, and reduced software cost, instant software updates, improved document format compatibility, so unlimited storage capacity, increased data reliability, universal document access, so latest version availability in the cloud computing environment, easier group collaborations, device independence. Next, disadvantages are requires a constant internet connections. It does not work well with the low speed connections. So futures might be limited. It can be slow and stored data can be lost. Stored data might not be secured. So cloud storage, create an account with the username and password. Content lives with the account and the cloud can be log on to any computer with Wi-Fi to find out the content and stored in the SkyDrive in the using the box. Role and boundaries of cloud computing. The role and boundaries of cloud computing. The cloud system involves different participants called roles. Cloud providers supplies cloud services and infrastructures. Cloud consumers uses those services. Cloud service owner is responsible for service quality. Next, the resource administrator. It manages underlying resources. Cloud auditor checks security and performance. Cloud broker connect consumers and providers. Cloud carriers handle data transfer between them. The trust boundary defines which part is secure and who control the boundaries limits. So these are all the loads: cloud provider, cloud consumer, cloud service owner, resource administrator, cloud auditor, cloud broker, cloud carrier, and a test boundary. So cloud consumer is a cloud provider is a cloud service infrastructure. Consumer is a user. Cloud service owner is responsible for the services. Resource administrator manages underlying resources. Cloud auditor checks security and performance. Cloud broker connected consumers with the providers. Cloud carriers handles data transfer between between cloud provider and consumers. Test boundary defines which part is secure and who control it. It helps to provides a responsibility for the cloud infrastructures. Next, a role ensures organization management and accountability. It provides guarantee uptime and service time limited. Consumers must ensure proper usage and data safety. Auditor maintains compliance and reliability. It together they form a complete cloud management services. Next, NIT infrastructure are having cloud consumer, cloud auditor, cloud provider broker. Next, it is mainly focus on so cloud consumers developed by NSDTN divided the cloud into multiple layer of clarity. Services layer contains SAS, PAS, and IaaS. Resource abstraction layer, it handles virtualization. Physical layer include servers, storage, and hardware. So cloud service management layer is manages security, performance, and configurations. The business support layer handle building and usage reports. It define roles of provider, consumer, broker, carrier, and auditor. Promote interoperability between cloud systems. It ensures transparency between cloud parties. So it improves governance and accountability. Use a reference model for cloud implementations, helps organization design secure architecture, encourage efficient cloud service delivery. It is a blueprint for frameworks model computing frameworks. Next one, IaaS. So in this IaaS, infrastructure as a service, IaaS provide basic in IT infrastructure, server storage and networking through the internet. It replaces the need to buy and maintain physical hardware. User rent virtual machines, storage space, and network components. It gives maximum control to use over the operating systems and applications. The cloud provider manages only the physical architecture. Ideal for system administrator and IT architects. User can scale resources up and down easily. So cost depends on actual usages. It allows a full customization of computing environment. Commonly used for hosting websites, testing, and backups. Security is handling jointly by provider and the user. So users offer flexibility and high performance. Example, Amazon EC2, Microsoft Azure, Google Compute Engine. I said like renting a virtual data center. Virtual hardware on demand. IaaS is a virtual hardware on demand. Next. PAS, also known as platform as a service, is a complex platform for developing and deploying the application. It includes operating systems, programming tools, and running environments. Developer can build app without worrying about servers or storage. It provider manage infrastructure and middleware. User focus only on coding and deploying applications. It reduces development time and cost. It offers scalability, collaboration tools with automations, updates. So ideal for software developers and programmers. So PA supports multiple programming language and frameworks, encouraging teamwork among a teamwork among distributed development teams. So it reduces complexity in applications lifecycle management. Example, Google App Engine, AWS Elastic, Microsoft Azure App Services. Next, it like renting a ready-to-use lab for app creations. PAS is a ready platform for developers. Next, SA, software as a services. Software as a services delivers software applications over the internet. User access the software through a web browser, no installations needed. The provider managed everything, servers, update and data, ideal for end users rather than developers. It is a subscription mode. User pay monthly or yearly. Example include email file storage and Office software, highly scalable, can be used on any device anywhere. Users always get the latest versions automatically, reduces the cost and time for maintenance. Perfect for collaboration and remote work. Data is stored securely in the cloud. It is suitable for common small business and individuals. So Gmail, Dropbox, Microsoft 365, Salesforce, it is also called as the example of SAS. SAS is a software ready to use online. It buying to no need to buying on the database. So parameters and the usage abbreviation. SAS means software as a services. IaaS means infrastructure as a services. PaaS means platform as a services. Potential user, it is used by end users. Network architects uses, mainly used by the developers. Prerequisite technical knowledge depends on does not need technical knowledge. Basic technical knowledge is needed. Require advanced technical knowledge. Conception, total abstraction. Abstracts only the underlying hardware resources. Abstract the under hardware software application services. So level of control. Total control and flexibility can be exercised. Minimum control and flexibility can be exercised. Moderate control can be exercised. Cost. Minimum cost is involved, high cost is involved, and low cost is involved in that. Example, cloud computing. So stack, Microsoft Office and Dropbox, Microsoft Web Services, Microsoft Azure and Google Cloud, Oracle, Google Shift and AWS Elastic Bench Stacks. So cloud deployment model, a cloud deployment environment is the virtual or physical infrastructure where cloud applications are hosted and maintained accessible over the internet. So development model, virtual machine, emulated computers on a hosted computing environment. The container having lightweight, isolated environment for applied methods. Our serverless computing mainly focuses on manage the servers as you only pay for what you use. Next, Google App Engine. The Google App Engine is a fully managed serverless platform as a service offered by the cloud computing environment. It manages developers to build, deploy, and host scalably wild applications on Google's infrastructure without the need to manage underlying servers or infrastructure. So GA is a platform as a service offered by Google Cloud that lets developers build and host web application on the servers. So developers it provides the supported languages Python, Java, PHP, Node.js, Ruby, and .NET. So it provides automated scaling for computing resources based on the application's traffic. And integrated services, Google Cloud Services is like cloud data store, cloud storages, and cloud SQL. So sandbox environment is mainly used to isolate application from better security and resource control. Flexibility and standard environment. The standard environment is fast startup, automatic scaling, and fixed runtime versions. Flexibility environment provide custom runtimes, manual scaling, and more control. Pay as you go model. You only pay for the resources that your app actually uses the version. The version control mainly focused on deploy, test, and rollback easily. Next, Amazon Web Service. So Amazon Web Service is a comprehensive cloud computing platform provided by Amazon, offering cloud computing power, storage, and other cloud services over the internet. So it mainly used in the contact from the user to from submit request to the API gateway. The API gateway forward the message to a AWS Lambda. The AWS Lambda forward to the AWS software exponential systems, and it forward to the third party mail service through the business accounts. So it can help us to determine the global infrastructures available in the cloud computing environment. It mainly focuses on EC2 elastic computing, cloud for scalable web servers, and Lambda for serverless computing. It provides S3 simple storage services for EBS elastic computing cloud platform for the achievement storage. So security and compliance is mainly focused on security encryptions and complication serving for the throughout the enterprises. So advantages and disadvantages are AWS. Advantages is scalability, flexibility, cost effectiveness, reliability, security, and innovations, global reach. Compare with the global Amazon web service. So in disadvantages, complexity, cost, vendor lock-in, potential downtime, security concerns. So Microsoft Azure. So Microsoft Azure is a cloud computing environment to build and deploy, manage applications through the global network and data centers. It is a cloud computing platform offered by Microsoft, provides storage, networking, and other cloud services. The services models are IaaS, PaaS, and SaaS. The global presence is mainly used for multiple regions and availability zones worldwide for reliability and the disaster recovery. So it mainly focuses on storage services is block storage, file storage, and pin storage, and page storage, and disk storage. So provides Azure SQL database, Cosmos DBS, Azure database for the Postgres SQL, and MySQL. So it including network services, virtual LAN, load balancer, VPN gateway, and content delivery network CDN for the security connectivity. Ideal for enterprise applications, web and mobile apps, AI using machine learning, IoT solution, and hybrid cloud environment. So this is application library data in the cloud assures the cloud computing fabric with the services bus, access control, caching with the app fabric container. The SQL Assure database provide the services to the provider through the consumer. Windows Azure having fabric controller, compute storage. It all belongs to the cloud computing environment. So next, last, Eucalyptus in the cloud computing environment. It is a Linux-based open source software architecture. The cloud computing also store a platform that implement infrastructure as a service, and Amazon easy to provide simple storage services S33. So it mainly used to retrieve the data in the use ECS. The Eucalyptus is mainly returned to the architectures. It means deploy, monitor, and manage the Azure resources, Azure PowerShell, Azure PowerShell, Azure CLI. So the connectivity on-premises systems via VPN, other Azure services like SQL database. The management system, compute systems, and the storage systems is in physical layer. The portal CLI PowerShell is in the management layer. The computers and the VMS application services, functions, blob, table, queues in the storage layer. So in the Eucalyptus, CLC and Waters, the private network through the cloud computing environment, cluster A and cluster B connected with the private network. So it is mainly used in the IaaS and SaaS, similar to the Amazon Web Services. It is mainly used for AWS EC2 API and S3 API. Next, the cloud controller component. Now, the cloud controller component that manages the entire cloud environment, including resource allocation and user request. CC cluster request, NCSL node controller. So cloud cluster controller manages cluster of node, schedules virtual machines, and communicate with the cloud controller. So the node controller, it acts as a physical role of physical servers and handle the execution and management of virtual machines. So hybrid cloud support is a combination of both cloud controllers and cloud consumers. So uh, overview of cloud computing environment is scalable and elastic. AWS compatible. It provides a private and hybrid cloud. It manages secure and manages systems over the internet. So overview, cloud computing is on-demand delivery of IT resources like computing power, storage, and software over the internet. Instead of buying and maintaining the own physical data structure, we need to use Amazon Web Service, Google Cloud, and Microsoft Azure as needed. The model offers flexibility, scalability, and cost effectiveness, eliminating the need of direct management of physical infrastructures. So download from this data structure, you can use the cloud based on your storage. The app lives in the so save file in the app. Throughout the internet, we can access the cloud files. Thank you.
Presentation, is it enough, ma'am?
Yes, enough, ma'am.
Okay, for our participant, if you have any question for the speaker, please add them to the chat or you can raise your hand. Yeah, we have some question from participant, ma'am. Already read in the Zoom chat. For first question, is cloud computing truly democratizing access to technology, or does it create new form of dependence on big technology corporation? The question already read in the Zoom chat also. Thank you.
Your cloud can cloud computing can never use 100% secure for the nature of the digital system using vulnerability throughout the architecture, encryptions, and compliance throughout the risk can be used to level by acceptable for more use. It is a shared responsibility model and never can be used by the secure applications. The human error can access with the problems. It evolving threats over the authentication's purpose.
And then the second question, can cloud computing ever be 100% secure, or is that a vulnerability and unavoidable trade off for convenience? The question from Miss Corey. Thank you.
It mainly used for database services, networking services, and it provides secure and complements throughout the. It reduces and increases the control over the process. It lost direct control over the physical infrastructure by gain frame and more secureable throughout the internet using the automation schemes.
Okay, thank you. And then the last question, does the shift to the cloud reduce or increase organizational control over their own data? Thank you.
So So you only pay for the resources, CPU, memory, bandwidth that your app actually can use. The developers then deploy, test, and roll back for the services. The web applications, API, and mobile backends with high availability and a minimum maintenance.
Okay, thank you, ma'am. I guess no one else asking again. Okay, before I close this event, for our participant, please open your camera. I will take a picture on the count of three for documentation. Okay, one, two, three. Okay, another one. One, two, three. Thank you. Thank you for your keen cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Professor Sangeetha for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have a collaboration in the future with Arunai Engineering College. The visiting lecture for today and here. We hope to see you. So thank you and have a nice day. Thank you.